Hello, welcome to our presentation on the second way by Joseph Hughes and Sam Tadlock. The second way is, I guess, best described as helping to create a fast and consistent way of getting feedback from development to operations and back again. Ultimately, the goal of the second way is to create a safer and reliant and more resilient system of creating that loop. Key to that process is obtaining fast feedback. One of the things to achieve that is to understand that ultimately every system that is out there is not going to be perfect. You're not going to be able to achieve perfection. So pretending that mistakes or problems aren't going to arise isn't going to be productive. So what you need to do is not just understand and appreciate that they would happen, but realize that what we do in response to when a problem arises actually does matter. And as a result of what we do, getting back the feedback to customers is going to be the most important way to create a system that's going to improve quality, reliability, and safety. So understanding mistakes. Every complex system is going to be built in a way where you're not going to be able to avoid problems arising. They will happen, and ultimately what makes them more complicated is that sometimes you can create checklists or best practices, but these checklists are not always going to be the most efficient way to solve the problem. Sometimes you can have a problem arise and you can address that problem in a defined way, but the end result could actually change. That's what happens when complex systems are put together. Sometimes one thing that you do doesn't result in the same actions every single time. So it's not enough to just have a system that you've planned for with checklists and programs. What you have to do is have a system that's designed and developed specifically to address problems as they arise or address unknowns as they arise, not just assume that you know everything that's going to go wrong and plan for those. So the actions that we take, like we said, is really important, and those kind of break down into kind of a couple different areas. The way you develop the systems before problems happen and what you do when they occur. So prior to problems arising, what you want to do is create a culture without fear. Now, part of the reason for that is if a development team or operations team is so worried about making a mistake that they overanalyze or are hesitant to do things, you're going to reduce productivity and reduce efficiency. And what you need is a culture or a system that supports testing and supports the process to make mistakes and correct them. And part of that system is ultimately to automate some important components of the process. So when you automate the build process, the integration process, and the testing process, what that does is that feeds that culture of not being fearful, because developers are going to be able to understand that any mistake or any flaw is going to be automatically implemented, automatically integrated, and ultimately automatically tested. So any flaw is going to be realized right away, and ultimately will put that together in a way so they're not going to be afraid to test things. They're not going to be afraid to move forward. They're not going to be able to make something happen. The other component of that is to create a pervasive telemetry. That's a little bit different than just creating a way of testing things or automating integration, because when you test if something works, that's one component. What you also want to be able to do is have a system in place where you can not only test if it works, but also test if it achieves the goals that you're ultimately looking to achieve from a big picture perspective. The other component of that also is not just does it achieve the end goals, but does it assist in the other departments downstream in achieving their goals as well. So having that automated process, or having that those systems in place that measure those things, is going to be very important to avoid problems that could arise, but also respond to them appropriately when they arise. Okay, so when they do arise, ultimately what happens is you need to have systems in place so that they don't perpetuate the problem throughout the rest of the production process. So one of the things to do is to actually stop production. That's ultimately the idea behind that is when a small error or a system can't be solved or can't be solved quickly, it's better to actually stop production in the entire cycle than it is to slow down one component of it, because it'll create a bottleneck. And actually one of two things will happen. You'll either create a bottleneck that will require attention to fix, or you're going to perpetuate that problem all the way throughout the process and end up costing more time and energy and resources to fix it in the end. So to create a process where you can actually stop production so that resources can address the problem that takes place, and that leads to actually solving the problem. If it can't be immediately if it can't be fixed easily, it's better that everybody in the process swarms the problem and fixes it immediately, not perpetuate it, not procrastinate, but in the end put that all together. And this allows everybody to bring all of their resources to bear on the problem, which facilitates it getting corrected faster, and also facilitates knowledge and understanding of the problem and what happened. The other components to do when we look at when problems occur is we also want to look at it from a standpoint of how we can optimize everything downstream. So whatever actions we take, is it improving the process downstream for other work centers? Because one, we don't want to perpetuate a problem which will cause another problem or snowball into another center. But also we want to make sure that our fix doesn't snowball into the next section downstream. All right, so the outcomes of this is a little bit about what we talked about. Ultimately, we want to shorten cycles and shorten these feedback loops so that we can resolve problems quicker. As this loop happens in a more quick and efficient way, any problems are going to be fixed very, very quickly. The other part of it is as we do these actions, as we do these things to create a system, what it does is it embeds the knowledge where it's needed. In other words, everybody in the production cycle is aware of problems and is thinking about how to improve it for everyone else in the process. So everyone is learning, everyone is growing, not just from mistakes, but also from discoveries and from things that were learned. And then the final component is ultimately understanding that responding or helping us to understand, helping us to respond to customers, both internal and external customers. The end customer that's going to use the product isn't always the person that we're developing something for. Sometimes the end customer is the next stage in the production process, and if we're responding to them for what they need, that's going to ultimately do that. And creating these loops and creating these feedback loops is an important and integral part of responding to their needs as well as the end result needs. So in closing, every system that's created is never going to be perfect, but the purpose of the second way is to help make that process more safe and more efficient. And ultimately, the second way helps achieve that goal. Thank you.